Okay, so I've attached a PowerPoint that goes through finding the angle between two planes. Again, it's got the diagrams showing it in 3D. I won't, obviously in an exam, you won't be drawing it in 3D. So I'm going to work through the example that's on the PowerPoint for you. So you're asked to find the acute angle between the planes with equations r dot 4i plus 4j minus 7k equals 13 and r dot 7i minus 4j plus 4k equals 6 respectively. Okay, so if we think about that 2D wise, if you start by drawing a diagram, okay, now I'm going to go over this so you can see it a bit better. So if we start by drawing the planes, so imagine this is one of the planes and this is the other plane. Okay, this is the angle that we actually want to find, so let's call it alpha. Okay, but we've also got normals to planes, because remember this is the normal that's perpendicular to this plane, and this is the normal vector for this plane. Okay, so we know the equations of these two, we know the vector directions of these two normals. Okay, so if I'll do them as dotted lines again. Okay, so there's normal 1 and this one is normal 2, and remember your normals are perpendicular to your planes, so we've got our right angles there. And then we can do a similar approach to finding the angle between two lines. We know the vector direction of these two normals, so if we find this angle here, call it theta. Okay, if we find this angle here, we can then work out what this angle that we actually need alpha is. Okay, so that's all I've written there. Draw a diagram showing the planes and the normals. The angle that we need is alpha, and obviously theta is the angle between the normal 1 and normal 2. Okay, so we can then write out, like we've just said, normal 1 would be 4i plus 4j minus 7k, and normal 2 is 7i minus 4j plus 4k. Okay, and using the same process that we've done already, we can find the angle using dot product. Okay, so we've got cos theta is equal to normal 1 times normal 2, yeah, doing your dot product, and over the modulus of normal 1, modulus of normal 2, which is your Pythag. Okay, working those out, you've obviously got 4 times 7, add 4 times minus 4, add minus 7 times 4, and then you can obviously put the roots into your calculator. So we end up just working through it with cos theta is minus 16 over 81, so then we can work out that theta is 101.4. Okay, now remember theta is this angle here. Okay, and because these two are both right angles, because of obviously the perpendiculars, all four angles would add up to 360, but as these two are 180, these two here must add up to 180. So if we do 180, take away the 101.4 that we got for theta, we'll get that the angle between the planes, alpha, equals 78.6 degrees.